Okay. Okay, so let's talk about Simone. Simone went to the outlet mall. Always a fun place. Found blowout sale. Sweaters were $5 and shirts were $3. The product of the number of shirts and sweaters she purchased is 30. So that means if one of them is X and one of them is Y, X times Y is 30. Immediately, you can pretty much eliminate every other answer choice after that. Because here, there's no multiplication here, there's no multiplication of X and Y here, there's division of X and Y, but that doesn't help you. Now, just to make sure that we didn't jump the gun, she said that she paid $45, which is 5 times the number of shirts, 5 times the number of shirts, 3 times the number of sweaters, 3 times the number of sweaters is $45, and that's it. Now, the question becomes, how many shirts and sweaters did she buy? Well, you can go on ahead and actually graph the two solutions. You know that your first equation is that y is going to be 30 over x. And you know that your second equation, you've got 3y is equal to negative 5x plus 45. And you go on ahead and you say y is equal to negative 5/3 of x plus 15. So these are the two cleaned up versions of the equation. You plug them into the calculator and see where they intersect. Or you could solve substitution, or you could have used a matrix, but my beloved regular children don't get to play with matrices as much as I would have liked. So we go to our problem and we say, okay, y is equal to, so we say 30 divided by x, and negative 5 divided by, we'll use the pretty fraction print. Alpha y equals 5/3, going to insert the negative, 5/3 of x plus 15, and we know from the domains that we probably want to go from 0 to 15, and from 0 to 15. And as you can see, there are 2 points of intersection. So we're looking at two solutions. So when we hit trace where x is 3, we have 10. That's consistent with A. And we trace again where x is 6. You have 5. That's consistent with B. Therefore, both A and B are reasonable solutions. Okay. Number 13, what system of equation can be used to find the length and width? They already gave you that the perimeter is 28 and the area is 40. Immediately, you can eliminate from consideration any equation that doesn't have x times y is equal to 40, which means D is out. Now, the other thing is you know that you have 2 y's and 2 x's, and they add up to 28. So, 2x plus 2y is equal to 28, that's the perimeter. X times y is equal to 40, that's the area, and C is our correct response. Adding the squares makes no sense because we're not dealing with a triangle, and of course you wouldn't just add once because you have more than 2 sides to the story. So that one's wrong. That's the best distractor answer right there. The next question is, what are the dimensions of the rectangle? You can find it pretty much the same way. Now, you will notice that in the interest of expediency, we're just going to graph it. So, once again, we can factor 2x plus 2y down. You divide everything by 2 and you say, okay, x plus y is equal to 14. You say y is equal to 14 minus x. To get y by itself here, you say, okay, y is equal to 40 divided by x. You then plug those into your calculator and see where they intersect. Now, this isn't the only way to do it, but since we're crunched for time and this was a time-limited test, use the calculator to your best advantage. 14 minus x, 40 divided by x. Now, again, 0 to 15 seems a reasonable domain enough. And when we graph, here we have our linear function, and behold, there are two solutions. Now, one of the things you can do, you can trace the point of intersection, 5, enter, 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 and it has 10 and 4, which is the same as 4 and 10, because multiplication and addition are both commutative. So 4 and 10 was your final solution there. Solve the system of equations. This one you would solve by elimination. However, you would find that there is no solution. What you notice is that here the slope of the first equation is negative 3 over 5. Here the slope of the second equation is negative 6 over 10, which reduces to negative 3 over 5, and thus you find that the slopes are the same. Since the slopes are the same, at no point do they intersect, and so there is no solution. And they are not identical because 10 over 15 is not the same. So, and also infinite solutions was not an option. So there we go. Solve the system of equation algebraically. Show your work to receive credit. If you punched it into the calculator, you didn't get any credit for it if you just gave me the answers. Now, what we will do is we will punch them into the calculator to confirm our answers. And then I'll show you how I got it. So you've got x squared minus 3x minus 6, and then you've got negative 5x minus 7. Again, sometimes it's helpful to have a roadmap. In this case, there were no restrictions on the domain, and so we probably want to set our window to something normal. So we did the zoom standard. Here we have a quadratic, and here we have a linear equation. Now it's not terribly obvious from where we are if that's one point of intersection or two. So we'll find that out. So what we're going to do is we're going to start with the very elementary idea that y is equal to y, and so we are going to say, okay, x squared minus 3x minus 6 is equal to negative 5x minus 7. At this point, I would add 5x to both sides, and I would add 7, which we could do as a single stroke. So plus 7 here, plus 7 here, add 5x here, add 5x here. Like terms are combined, and you have 0 on the right. Again, now that we're in Algebra 2, you should be able to do a combination of like terms more than one at a time. So we have x squared plus 2x plus 1. At this point, you should immediately recognize that this is a perfect square without having to do the quadratic formula. This is in actuality x plus 1 quantity squared is equal to 0. You then recognize that there is only one solution and that x, so to solve you have x plus 1 is equal to 0 because the square root of 0 is still 0, and x is equal to negative 1. Having found the solution for x, you then verify to make sure that the solutions for y are consistent. So, if I evaluate y where x is 1, I have 1 squared minus 3 times 1 minus 6. That's equal to 1 minus 3. I'm sorry, negative 1 squared. X is equal to negative 1. Y function evaluated at negative 1 is negative 1 squared plus minus 3 times negative 1 minus 6. And so this becomes positive, this becomes a positive. You have 4 minus 6, which is negative 2. And we have to make sure that that's consistent with the other one. Y evaluated at negative 1 is equal to negative 5 times negative 1 minus 7, which is positive 5 minus 7, which is equal to negative 2. And so lo and behold, in both cases, we are left with a solution if x is a negative 1, y is negative 2, And that's your final answer.